Dear students, in last class we have studied the definition of DFT. Today we will study the frequency spectrum using DFT, and then we will solve one problem on computation of DFT. The DFT x of k is a discrete function of frequency of the discrete time signal, and so it is also called discrete frequency spectrum of the discrete time signal x of n. So what is x of k called as? X of k is called as a discrete frequency spectrum of the discrete time signal x of n. And yesterday we also learned that x of k is a complex valued function of k, and so it can be expressed in rectangular form as x of k equal to xr of k plus j xi of k, where xr of k is real part of x of k and xi of k is imaginary part of x of k. Now the magnitude spectrum of x of k is given by absolute of x of k, and that is equal to under the root real part of x of k whole square plus imaginary part of x of k whole square. Since xr of k whole square plus xi of k whole square is obtained by x of k and complex conjugate of x of k, we can write the magnitude spectrum of x of k as x of k into x of k complex conjugate. Here it is multiplication sign, don't take it as x. The phase function or phase spectrum of x of k is given by angle of x of k, that is equal to tan inverse of xi of k by xr of k. Now we'll take one example here to compute DFT of x of n. Compute four-point DFT eight-point DFT of a causal three-sample sequence given by x of n equal to 1 by 3 for n varying between greater than or equal to 0 to less than or equal to 2. X of n is equal to 0 else. It means that if n has any value other than 0 to 2, then x of n will be equal to 0. So that DFT coefficients are samples of Fourier transform of x of n. Solution. Given x of n equal to 1 by 3 For n less than or equal to 0, for n greater than or equal to 0 to less than or equal to 2, 0 otherwise. We have to find 4-point DFT and 8-point DFT. That means there are two cases. Case 1, n equal to 4. Case 2, n equal to 8. From given, we will write x of n sequence. X of n equal to 1/3, 1/3, 1/3, 0, 0. So n equal to 0 is here. By definition, n-point DFT of x of n is x of k equal to summation from n equal to 0 to n minus 1 x of n into e raised to minus j 2 pi kn by n. And the k value varies from 0 to n minus 1. In case 1, we have to find 4-point DFT. Therefore, capital N will be equal to 4. Now we will write this expression for capital N equal to 4. So x of k equal to n equal to 0 to 3. Here it is n equal to 0 to capital N minus 1, but n equal to 4. So 4 minus 1, that becomes 3. X of n into e raised to minus j 2 pi kn by 4. Now we will expand this. For n equal to 0, x of n will become x of 0 into e raised to minus j, and in the power if I substitute for n equal to 0, power becomes 0. So it is minus j into 0. Plus, for n equal to 1, x of 1 e raised to minus j 2 pi k into 1 by 4. plus for n equal to 2 x of 2 into e raised to minus j 2 pi k into 2 by 4 plus x of 3 into e raised to minus j 2 pi k into 3 by 4. But in the given sequence x of 3 is 0, therefore this term will turn to be equal to 0. X of 0 is 1 by 3. E raised to 0 is 1 plus x of 1 is 1 by 3. E raised to minus j 2 pi k into 1 is k only, divided by 4 plus 1 by 3 into e raised to minus j 2 pi k into 2 by 4. Now 2 1 ja 2 2 ja 2 1 ja 2 1 ja. Plus x of 3 is 0. On simplification we get 1 by 3 into the bracket 1 plus e raised to minus j 2 pi k by 4 plus 1 into e raised to minus j pi k. Now we will calculate x of 0, x of 1, x of 2 and x of 3 by putting k equal to 0, 1, 2 and 3 in x of k expression. So right here for k equal to 0, x of 0 equal to 1 by 3 into the bracket 1 plus, if we put k equal to 0 here, e raised to minus j 0 will get plus 1 into e raised to again 0 we will get, because here k is equal to 0 now. 1 into e raised to minus j 0. But we know that a raised to 0 is equal to 1. Therefore 1 by 3 into the bracket 1 plus 1 plus 1, that is equal to 3 by 3 and is equal to 1 now. This 1 is in rectangular form. In polar form, x of 0 will become 1 at an angle of 0. That means the magnitude of x of 0 is 1 and phase angle of x of 0 is 0 degree. For k equal to 1, x of 1 equal to 1 by 3 into the bracket 1 plus e raised to minus j 2 pi divided by 4 plus e raised to minus j pi. Now 1 by 3 equal to 1 plus, we will express this exponent form and this exponent form in cos theta and sin theta. So cos of 2 pi by 4 minus j sin of 2 pi by 4 plus cos of pi minus j sin of pi. That is equal to 1 by 3 into the bracket 1 plus cos of 2 pi by 4. If we cancel here 4 by 2, we get pi by 2. That means 90 degree. Cos 90 is 0 and sin 90 is 1, but this is minus j. So we'll get here minus j. Cos of 180 is minus 1 and sin of 180 is 0. So we get 1 and 1 cancelled here, minus j by 3 is equal to 1 by 3 at an angle of minus 90 degree. So magnitude of x of 1 is 1 by 3 and the phase angle is minus 90 degree. For k equal to 2, x of 2 equal to 1 by 3 into the bracket 1 plus e raised to minus j pi, because if I put k equal to 2, 2 into 2 will become 4 and 4 will cancel. And here if I put k equal to 2, it will become e raised to minus j 2 pi. Expressing these exponents in Sin theta and cos theta, we get 1 plus cos of pi minus j sin of pi plus cos of 2 pi minus j sin of 2 pi. That is equal to 1 by 3 into the bracket 1 cos pi is minus 1, sin pi is 0, cos 2 pi, that means cos 360. 360 degree and 0 degree are equal. Cos 0 is 1. So plus 1. Sin 0 is 0. So j into 0 will also be equal to 0. Here we get minus 1 and plus 1 cancelled. X of 2 equal to 1 by 3. In polar form, 1 by 3 at an angle of 0 degree. For k equal to 3, x of 3 equal to 1 by 3 into the bracket 1 plus e raised to minus j. If we put k equal to 3 here, it will become 3 pi by 2, because 2 will cancel 4 by 2. Plus e raised to minus j3 pi. One by 3 into the bracket 1 plus cos of 3 pi by 2 minus j sin of 3 pi by 2 plus cos of 3 pi minus j sin of 3 pi. That is equal to 1 by 3 into the bracket 1 plus 3 pi means 540 degree. 540 by 2 is 270. Cos of 270 is 0. Sin of 270 is minus 1. Minus 1 into minus j will become plus j. Cos 3 pi is minus 1. Minus j sin 3 pi is 0. So here minus 1 and plus 1 will cancel. Finally, we will have j 1 by 3. So x of 3 is equal to j 1 by 3. In polar form, it will be 1 by 3 at an angle of 90 degree. Therefore, the 4-point DFT sequence x of k is given by x of k equal to 1 at an angle of 0, 1 by 3 at an angle of minus 90 degree, 1 by 3 and 1 by 3 at an angle of plus 90 degree. Magnitude spectrum x of k equal to 1, 1 by 3, 1 by 3 and only 1 by 3. Here the entries are only the magnitudes of x of k. Phase spectrum angle of x of k is 0 degree, minus 90 degree. For real number angle is 0, so 0 degree, and here it is plus 90 degree. Now we will plot the magnitude spectrum and phase spectrum. K value here. On x-axis we will show k. Zero, 1, 2, 3, 4, 5. On y-axis we will take absolute of x of k. If I take third line here as 1, then second line will be 2 by 3 and the first line will be 1 by 3. For k equal to 0, x of 0 is 1, so here we will show x of 0 equal to 1. For k equal to 1, x of 1 is 1 by 3. Show that here. Similarly for k equal to 2 and k equal to 3. This is magnitude spectrum. Since x of k is periodic with periodicity of capital N, in first case we are having capital N equal to 4. Therefore, the fifth sample here will be same as the first sample. That means x of 4 will be equal to 1 only. Now if we join all these points, we get a curve here which is continuous, and this is nothing but magnitude of x of e raised to j omega, which means DFT is sampled version of the discrete time Fourier transform. Now we will plot here phase spectrum for k equal to 0. Angle is 0. For k equal to 1, angle is minus 90 degree. For k equal to 2, again angle is 0. And for k equal to 3, angle is plus 90 degree. So this is the phase spectrum of 4-point DFT of given sequence.